Well, this is John Black, Super Chemist. I'm here to do a simple video about how to get 2-propanol. I still have a few more weeks till I get my lab up and running. Until then, I want to do some easy videos about how to get. This is it. I mean, it's rubbing alcohol, isopropyl, 91% you should get because that's the azeotrope. You can buy it anywhere, Walmart, um, grocery stores, department stores. I don't know about Lowe's, but maybe hardware stores. Uh, Everyone knows what it is. You go in, drugstores have it. You'd have it by the toothpaste and hydrogen peroxide and that kind of stuff. Um, Anyways, that's why I did the last video, was because I was doing this one and it made me think of the pimples. But anyways, I got some facts here about it. Here's a drawing of it. Here's the formulas. There's a couple different names it's called. Some people might say, well, why is it called isopropanol? I mean, it's called propyl part comes from, there's 3 carbons. Okay, so that's propane, propyl. The 2 comes from where it's at. If you count these 1, 2, 3, it's on the 2nd carbon. That's where the 2 comes from. Now, isopropanol means that it's funny looking, okay? Because here's a picture of N-propanol. N stands for normal, okay? It has, and anytime it has N, that means it's a straight chain, and this is at the very end. It's the first one, okay? Now it's put inside there, and it's not on the first one. Sometimes they call it iso. Sometimes if it's the second one, it's sec. I want you to look at the word isopropanol and the word isomer. Look at how they're similar. That's because isopropanol is an isomer of N-propanol. It's a normal propanol. But that's the difference. See how this one it's on the end, and this one's on the second one. So anyways, here's a couple facts about it. The molar mass, density. And remember, I told you if you wanted to figure out milliliters per mole, you just put a little line here and divide this into that. And that your answer will be milliliters per mole. Freezing point, because it's a liquid, so I didn't put melting point. Boiling point, azeotrope boiling point. And you can see the azeotrope boiling point is slightly less, so it is a positive minimum boiling azeotrope. So it has the same configuration as ethanol and water, or methanol and nitromethane. Same type of configuration there, with the vapor liquid diagram. I'll get into the azeotrope part here in a second. There's a couple facts I want you to know about it. One is you can salt it out. You can salt out other alcohols too, but it's really hard. You need a better salt than sodium chloride, that's for sure. But isopropanol salts out pretty easily. It's very insoluble in salt water. So if you throw some sodium chloride in there until it all dissolves and you still have a little bit laying on the bottom there, so that you know it's saturated, it'll form 2 different layers, and then you can use a SEP funnel to get it out. But you will have trace amounts of water in your alcohol still, and you will have lost some of your isopropanol. I'm sure some of it will go into that salt water. I don't know how much, but that's always an idea. It's great for cooling baths. It's cheap like acetone. You can see the freezing point is minus 89, and dry ice sublimates at minus 78, so it won't freeze. So basically, any organic solvent or any solvent that won't freeze does the same thing. Like acetone would be good. You get your dry ice, which is frozen carbon dioxide. You can get it at the grocery store or a place that does beer. They make beer and stuff like that. You'd have to look in the phone book or whatever, someplace close. It's expensive where I'm at, so I don't really buy it. But you can get chunks of it. You throw it into the ice bath. I mean, the water bath, but the water bath is not water. It's isopropanol. You throw the ice in there and it'll keep the bath at minus 78 degrees Celsius. So, you know what I mean? And when the dry ice disappears, you throw some more dry ice in there. You know what I mean? It does have a pKa of 16.5, and water has a pKa of 14. And we all know that water is acidic and basic. So it is acidic and it is basic. It's very similar to water. I mean, think about it. Basically, H2O, all they did was this alkyl group, this hydrocarbon group, is just replacing the proton. It's just a cation replacing a hydrogen, positive hydrogen. All right, here's some more facts. It's a secondary alcohol because it's attached to a secondary carbon. What makes a carbon primary, secondary, or tertiary is how many carbons it's connected to. Okay, primary, you should know, that's one. That's the number one. It's primary, always is associated with one. I mean, if someone says what's your primary income, you're gonna say your number one income, your best income. If someone says what's your primary family, that's number one. That's first branch off of you, not 10 branches down with their cousins. You know, primary is prime, number one thing. What's your primary problem? What's the prime thing? You know, what's number one? So you should know the carbon has to be at the end of the chain to only be connected to one, right? Secondary, obviously second, two. How many carbons does it have? This is attached to one, two carbons. It's secondary. And that's our product there. Now what if it's connected, see this carbon? It's connected to one, two, three. They call that tertiary. You might say, well, tertiary, that doesn't connect to anything. But think of tri. Tri is always three. Tricycle, you know what I mean? Tri is three. Tertiary, three. So this is a tertiary alcohol because it's connected to a tertiary carbon. Secondary alcohol because it's connected to a secondary carbon. Primary alcohol because it's connected to a primary alcohol. Anyways, here's some facts about the azeotrope itself. The azeotrope is 91%. That's what usually they go by volume, and they jack it up to 91 because it's so close. So you get 91%, but here's a mole per mole, mass percentage, volume percentage, gram per 100 mole, mole per milliliter, boiling point, just some facts about the azeotrope. Once you get it up to say, 90% or whatever, 91% or somewhere close to that, what I usually do is I just use magnesium sulfate, or I recently got molecular sieves, so I'll probably try them out. Either one are good. Throw it in there to clean out all the residual water. You can just figure out how much you need by the percentage. I figured I'd do the math for you. Here's magnesium sulfate. It's a heptahydrate, so that means 7 water molecules. Here's the molecular mass for that when it has no water on it. That's what you would be putting into the alcohol to dry it, right? This is how much water it can soak up if you use this much of this. So you'd have 100, you could soak up 126 grams. You have to use 120 grams to do that. So you might as well just say that whatever you use for this is going to soak up the same amount. So if you use 100 grams, you're going to soak up 100 grams. You use 10 grams, you're going to soak up 10 grams. You use, you know what I mean? And you just throw a little bit of excess in. You can think of it that way if you want, because it is close. Let's say I have a liter of 91%, right? That you get at the volume percentage at the rubbing alcohol at the store, right? That's 1,000 milliliters. The density is 0.786, so I multiplied that to see how many grams I got. This should weigh 786 grams, right? Over here, you can see the mass percentage is for alcohol and for water. Water, it's 12.37, so I multiplied by 0.1237. I got 97.23 grams, and water is 1 gram per milliliter, so it's the same thing, 97.23 milliliters. My point is if I have a liter of this, that means I have 97 1/4 grams of water And to soak that up, I'd need to add in 97.25 grams of this. Okay, I would throw in my 100 grams of magnesium sulfate. I'd let it stir, let it sit for a while and stir, and the next day I would distill. I'd filter out the stuff, and then I would distill my alcohol, and then that way I would have pure anhydrous isopropanol, 2-propanol, propan-2-ol, whatever you want to call it. Another thing you can do is salt it out before you do this process here, and that way you won't have to put as much magnesium sulfate in. You know what I mean? You'd take your liter, you would put in some table salt and keep putting it in there until it was saturated, meaning there's so much in there that some of it's laying at the bottom. There's a little bit at the bottom, so you know that it's saturated. Then it will form 2 layers. Separate your layers in a SEP funnel, and what you have left is pretty much pure ethanol, or not ethanol, isopropanol. And then you just add a little bit of magnesium sulfate in to get that trace amount out, then distill it. You'd have some super pure 2-propanol. Now keep in mind, if you're recycling things like solvents, like isopropyl alcohol, if you distill this, you're not going to distill it to 91% azeotrope. I mean, I hope people understand that, especially if you do a simple distillation. I mean, it takes probably 3 or 4 plates to do that, which means you'd have to distill it 3 or 4 times with a simple distillation. With a fractionating column, you still have to do it probably twice to get it to 91. I mean, getting it up to close to 91 is easy. Getting it to actual 91 is almost impossible. So keep that in mind if you do recycle your solvents. Don't just distill it once and think you got 91%. You ain't got no 91%. Calcium chloride dry stuff too, but it forms a coordination complex with 2-propanol. So if you have trace amounts of isopropanol in something and you want to get it out, you can use the calcium chloride to complex it, and it will precip out and you can filter it out. But as for what we're doing here, it really doesn't do any good. But I wouldn't use this to dry your alcohol because it will just complex with it. We did make, I think, propene with isopropanol, and in the future I'm going to make acetone with it, and also I'm going to make isopropanol with Grignard reaction. So anyways, that's about it for now. Like I said, my videos give me a few more weeks and I'll have my lab open, and have a great day, and always remember, science is great.